Okay, so for the last lesson of this unit, you're going to need Desmos, so just a heads up on that. For this lesson, I want to explain how to analyze a graph of a polynomial. So I'm just going to start with some vocabulary. So the first two terms are going to be what we focus on. Even and odd functions I am also cutting out of this lesson right now because I want to just focus on the basics of understanding how to analyze a graph of a function. So the first thing I'm going to define is a local maximum. And a local maximum is a point that is higher than all points near it. And this isn't a great definition, but a local maximum, if I'm looking at a graph here, and it's kind of a wavy graph like this, the local maximums would be this point and this point. They are points that are higher than all the points immediately to the left and the right of them. Okay? A local minimum is just the opposite. It is a point lower than all points near it. So in that same function, or that same graph, that point would be a local minimum. It's lower than all the points below it. So those are local maximums, local minimums. So just to recap some of this, the relationship between zeros, factors, and intercepts and solutions, they all basically mean the same thing. But a zero is what we find with a function. Functions have zeros, okay? Polynomials have factors. Solutions come from equations, and intercepts are on graphs. But they all mean the same thing. They all connect to the same number, okay? So example 1 does a good job to talk about intercepts to help us graph a polynomial. So what I'm going to start with is understanding the x-intercepts of this function are -3, +2. And if you remember from the last couple lessons, 2 is a repeated solution. Okay? 2 is a repeated solution. So first I'm going to graph my intercepts. Okay? I'm going to graph my intercepts. And really what I want to do here is I want to just pick some points to fill in some of the blanks. So essentially, I'm going to go -3, -2, 0, 1, 2, because I know this is -3, 0, I know this is 2, 0, right? And essentially what I'm doing with -2, 0, and 1, or -2, I should have done -1, it's fine. But -2, 0, and 1, I guess I just picked random points. Sorry about that. But -2, 0, and 1, I'm just going to plug in. So if I plug in, it's positive 2.67. If I plug in 0, I get out 2. If I plug in 1, I get out 0.67. So I'm going to graph those points, and a lot of this is just more or less estimation, okay? So I know that between these two functions, or between these two x-intercepts of the function, that the graph is going to kind of peak here, and it's going to kind of come back down. The main thing to know with this function is the end behavior. So this function is positive on the front, and it has an odd degree. The reason it has an odd degree is because the first factor has 1, the second factor has 2. This has a degree of 3. So end behavior being positive, and it looks like I wrote the word dog here. Odd degree, D-E-G. So what that's going to look like is up to the right, down to the left. And that should kind of make sense because -3 crosses through and 2 bounces off because it's repeated. So coming back to things we learned before, just applying those different things. So understanding some end behavior, understanding how the intercepts interact with the x-axis, that's important, okay? The next concept here is called the location principle. What this basically says is if I have two x values, where one x value results in a negative y value and the other one results in a positive y value, that there's an x value in between them that is 0. So it helps us locate the real zeros, the points that fall on the x-axis. Those are our real zeros. So looking at this table, using that location principle, we're looking for when a y value goes from positive to negative or negative to positive. So if I look carefully right here, I know there's a 0 between those two x values that correspond. So I know there's a 0 between -1 and 0. I can also look and see right there. There is a 0. There's a 0 between (1) and 2, x values of 1 and x values of 2, because the inputs go, or the outputs go from positive to negative. Now, we're going to use graphing for most of this. So I could graph this and find the real zeros, okay? I could find all the real zeros. There are 3. But the main thing I wanted you to understand there is how to find them by looking at the table, how to narrow it down by looking at the table. Because if I were to do this and find all my real zeros, that would be that synthetic division stuff we talked about before. But again, we are just looking at how to find out where between which two x values does a 0 occur. So the last part of this lesson concerns all of the vocabulary that I kind of want you to know for this lesson. Turning points. We talked a little bit about local maximums, local minimums. Turning points correspond to our local maximums and minimums. So that's where a graph goes from increasing to decreasing or decreasing to increasing. So local maximums, the point is higher than all nearby points. Local minimum, point is lower than all nearby points. Those turning points tell us where those intervals for which a function is increasing or decreasing. Okay, so I just want to show, and maybe I'll do this a little bit differently. Increasing for this graph, I'm going to do red. So the function is increasing on this interval, it is increasing on this interval. Where it is decreasing, I'll do in blue. It is decreasing over this, actually green might be better. I'll do green. It is decreasing over that interval. So understanding those intervals of increase and decrease, I think, is the main sticking point here. That can be a little tricky. The rest of it, I think, is fairly simple. So in example 3, we're just using Desmos to find these values, okay? So I'm going to pause myself. I'm going to put a Desmos screen up on the screen for you, and I'll kind of explain through the different vocabulary terms. Okay, so hopefully you can see kind of where my graph is at here. What I want to show, X-Intercepts, this graph really only has one. The X-intercept, and we can round, that's okay. I could do -1.20. That's my only x-intercept of that graph. A local maximum would be this point, 0, 6. Okay, so 0, 6 would be my only local maximum. My local minimum would be the point 2, 2. Okay, so that helps me find my turning points. Okay, the tough part here is to understand intervals of increase and intervals of decrease. So let me highlight the intervals of increase. Let's do that in green. So this is an interval of increase. As I read the graph from left to right, it is going up. This is also an interval of increase. As the graph goes left to right, it goes up. So I'm describing two intervals here. The first interval, I'm defining these on x values right now. So the first interval is all x values to the left of 0, meaning all x values less than 0. So this describes to the left of 0. Okay? The other interval of increase is all x values to the right of 2. So I would say x values greater than 2. So that describes my intervals of increase. Now I'm going to do in blue, I'm going to do my interval of decrease. So my interval of decrease here is x values from 0 to 2. So the inequality I'd write for that is a compound inequality. So that compound inequality describes all x values between 0 and 2. Okay? So finding those intervals of increase and decrease are important. But remember, you always read the graph from left to right, and you describe intervals of increase and decrease using x values. So what I think would be a good idea right now, I'll erase this out. What would be a good idea right now is for you to pause the video and try part B on your own. I think that might be a good exercise for you to try part B, graph it on your own, see if you can find those important parts, okay, for the graph, those important terms. So I'm going to pause my video, allow you to try it, and then I'll come back and explain my solution, my answers at the end. Okay, so this one's got more going on, but X-intercepts, it has 4. So I just clicked where those points occurred for the X-intercepts. Local maximums, there was only one. It was this point in the middle here. I'll show you the yellow. This point right here is our local maximum. It had 2 local minimums, meaning it had 3 turning points. So there were more intervals of increase and decrease here. So my intervals of increase, tried to highlight them in green, but the first one was between negative 0.6 and 1.1. The second one was to the right of 4. So that represents my 2 intervals of increase. Intervals of decrease were values to the left of negative 0.6, and then values between 1.1 and 4. So that's how I described the main features of that graph. So the practice really concerns exactly what I covered in the notes. So you should be ready to practice, and once you're finished up and you're ready for the quiz, let me know and I will send that to you.